Today on MRS TV, we spotlight the Fred Kavli Distinguished Lectureship in Materials Science, a plenary session showcasing bold ideas shaping the future of the field. We're joined by this spring's plenary speaker, Kazunari Domen, whose work in photocatalytic water splitting is advancing solar-driven hydrogen as a clean energy source. We'll explore how close this technology is to real-world use, the breakthroughs driving it forward, and what it means for the future of global energy.
Okay, at present that we have to improve our system several places. The most important one is the improvement of the photocatalyst efficiency using the sunlight. Then it takes about probably a few years. On the other hand, we are now constructing a water splitting panel to collect the evolved gases and also separate the hydrogen from the mixture of hydrogen, oxygen, and water vapor. It is also an important part. I think that, however, that we are now collaborating that part with some company people, and they are also very good at to developing new type of reactors. So I believe that the most important part is development of highly efficient photocatalyst itself. Yes, and it takes about. I hope that maybe 3 or 5 years will be enough, because at present we know that what kind of semiconductor property of the photocatalyst should be improved. Then we are now struggling to improve our preparation procedure. Our conventional preparation procedure is not really so good because it is contaminated, especially by oxygen. So that we are now constructing a new system. I hope that it will be working well. It is now possible to achieve a high quantum efficiency, and also we are now able to use long wavelength photons in the visible region, more than 600 nanometers. It is very important to get the high solar to hydrogen conversion efficiency. So that is very important. Those work is not only our group, but some other groups are also working very hard. So that now we have a lot of choice to choose suitable photocatalyst. And another breakthrough is that if we use a particular type photocatalyst, we are able to extend relatively easily to wide area. If we use, for example, photoelectrochemical systems, it is not so easy to extend to wide area because it is probably due to one reason is that electric resistance of the photoelectrode, and another one is that produced pH gradient. That is the pH difference at the anode and cathode side. It becomes a reverse potential, so that in that case we need to mix the solution. But in the case of the particulate photocatalyst, it is a particle size is only about a few hundred nanometers, so we don't need to worry about that. That's the kind of pH gradient. That's why we can extend to very wide area, and even if we extend to very wide area, the system is the efficiency is exactly the same as far as we can prevent a reverse reaction. I hope that if we'll be able to install our new green hydrogen production system in about 5 years, we like to go outside, other than I mean that outside Japan. Then that we like to collaborate with some countries which has a very wide area, including some desert areas. Then in that case, we will be able to extend a very wide area. So if it will be possible, I believe that we will be able to produce a large amount of solar hydrogen on a large scale. And I believe that the cost of the green hydrogen can be very cheap. So that's, I hope that within 10 years we will be able to go outside and to construct such a kind of wide, uh, large-scale green hydrogen production system. Actually, that this kind of energy research is will be continued for a long period. So, although that we will be able to succeed in install that the first stage of the green hydrogen production system, and always that system has to be improved, and then that means that it takes a long period. So I believe that the young people's challenge will be more and more important. So that I believe that they have they are very ambitious people will be have a very good opportunity to achieve that very great breakthrough in the future. So that yeah, actually climate change and the energy crisis is a very big issues in the world. So that young people's power is no doubt we need young people's power in the near future. Yeah.